Okay, welcome back. Lesson 13, further solving linear equations in one variable. So we've done a light intro to solving equations. Now we just want to go further into our practice. Let's begin. Friendly reminders before we get started. When you say something like 3x minus 2 equals 7, what you're really looking at is a linear equation or first degree equation in one variable. So notice that you don't see, when you're looking at an equation like this, you don't see the variable being raised to the second or third power. So you see x is raised really to the first power, hence first degree. And it's a linear equation. As we will see later, if we were to graph it, we would get a line, but that's coming down the pipeline. Okay, the exponent on each x is 1, and there is no variable below a fraction bar, so you don't see like a 1 over x or 2 over x. You don't see the x underneath the fraction bar. So it is an equation of one variable because it contains one variable x. So you're noticing you also don't see x's and y's. So getting used to the language, because there will come a time when we are looking at higher degree equations and bivariate equations, but that's down the pipeline. So make sure you understand which property to use to solve an equation. Do you use what's called the addition property of equality? So like here, for example, to undo addition of 5, we would subtract 5 from both sides to isolate the variable x. And clearly, if we did that, 5 minus 5 would cancel, 8 minus 5 would be 3. And that's called the addition property of equality. It's basically how is x connected with 5 by addition, so to undo addition we subtract to isolate x. The game is always isolate x. Okay, here we would have to use the multiplication property of equality. Why? Because 3 is connected with x by multiplication. So to undo multiplication, we divide both sides by 3. And voila, we would get 4 as our final answer. So just always bearing in mind, do I use what's called the add-op property of equality, where you add the opposite to both sides of the equation, or do you use the multiplication property of equality? Let's dive right in. You see a lovely equation right here. You see our equations are getting longer. But general recipe, if parentheses are present, use your distributive property. Combine any like terms on each side of the equation. Use the addition property to rewrite the equation so that variable terms are on. I like to get my variables on the left and my numbers on the right in terms of balancing the equation. And use the multiplication property of equality at the very end to get your x isolated. And then check your solution, of course. Step 5. All right, here we go. So as soon as you see, 3 connected with x minus 1 like that, you know you're going to have to use the distributive property. But be careful, because is he positive 3 or is he negative 3? So this negative here, note to self, actually belongs to this 3. So you're actually sending through a negative 3. Note to self, negative 3 gets distributed through. So take a moment, 2x minus 3x, and then negative 3 times negative 1 makes positive 3 equals, and if you like, hit pause and see if you can beat me to the punch. Okay, then you're looking for like, note to self, like terms, and always keep your eye on the equals sign here. I'll even put the eyeball. Here's the eyeball. Keep your eye on the equal sign and combine like terms on the left side of the equal sign. So 2x minus 3x makes negative 1x plus 3 equals negative 2x plus 4. When you arrive here, I always tell people do this. Letter, number. Letter, number. Letters on the left, numbers on the right. Okay, so that means I would like to take negative 2x and toss it across the equal sign. But I can't just toss it across the equal sign. I have to move it over there legally, which means I'm going to add 2x. How come? Well, negative 2x plus 2x is gone, right? But if I add 2x to that side, I've got to add 2x to that side of the equation. Okay? So negative 1x plus 2x makes 1x, and then just keep recording everything. Plus 3 equals, remember these wiped out, and you still have your 4 over here. Okay? Now you've got letter, number, number. you want to bring this number over here to be with the other number. You can't just toss it across the equal sign, so you're going to, and I always say, what's the opposite of addition? To undo addition, we subtract. So we're going to minus 3. 3 minus 3, gone. 4 minus 3 is 1. Record the equal sign. Now you have 1x equals 1. That means the same thing as x equals 1. Yay! So we arrived at x equals 1. Remember we said it's ideal to check. It's ideal to take that answer of 1 and throw it way back into the original. So I'm just going to make a little side note here on checking. So I always say if time permits on a real exam, check it. So we got x equals 1, so is it true that 2 times 1 minus 3 times 1 minus 1 equals, so notice that everywhere I see an x I'm storing a 1, equals negative 2 times 1 plus 4? So I kind of ran out of space there, but well, 1 minus 1 is 0, and 0 times anything is 0, so that whole thing's going to 0 out. 2 times 1 is 2. So I'll have 2 minus 0 equals negative 2 times 1 plus 4. Well, 2 equals, here you have a negative 2 plus 4. Aha, 2 equals 2. Now here's the crazy thing. So we got a true statement. We know our answer checks out. A lot of times students tell me that they get the answer and then when they throw it back in, they actually goof up in the checking it. Well, if that happens, then you're just going to have to go in faith that your answer's right. It does happen sometimes where the checking procedure goes astray. If you do a lot of repetition, you get comfortable. Obviously, you're watching my videos. You will start to get the right answer repetitively. Let's try again. Again, as soon as I see parentheses, I gear myself up for the distributive property. And I ask myself, am I distributing a 4 or a negative 4? Well, that negative belongs with that 4. So if you want to make a reminder here, distribute negative 4. Okay, well then negative 4 times x is negative 4x. But negative times a negative makes a positive, so that'll be positive 32. This negative 3 here just follows along. So negative 3 minus 4x plus 32 equals, send this through, negative 2x minus 2. How come? Because negative 2 times 1 makes negative 2. When you arrive here, note to self, look for like terms. So, for example, negative 3 goes with 32. Goes with meaning combine, meaning add. So negative 3 plus 32 makes 29, right? So you'll have negative 4x plus 29. So I'm going to just note to self there that those are like terms, equals negative 2x minus 2. Okay, when you arrive here, letter, number, letter, number. Letters on the left, numbers on the right. You can almost sing it to yourself. Letters on the left, numbers on the right. So let's take negative 2x. We want to toss it to the left, to the left, to the left. But you can't just toss it to the left, so you have to do the opposite. Add 2x. So it makes sense, because negative 2x plus 2x, gone. See, you want them to disappear on that side of the equation and move over to this side of the equation. Okay, well, negative 4x plus 2x makes negative 2x. And here, you have a 29, so let's just record that 29. Record everything. Bring down the negative 2. So record everything. You can even make an arrow there if you like. And see what you're left with. Well, now we're left with, and I'll highlight it here, letter, number, number. We want the numbers on the right. So I want to bring 29 and toss it across the equal sign, but I can't just toss it, so I'm going to subtract it, because the opposite of addition is subtraction. And 29 is connected to x with addition. Alright, so now he's gone. 29 minus 29, gone. I have negative 2x equals negative 2 minus 29 makes negative 31. And You can say it as negative 2 plus negative 29. You could say it like that too. Still negative 31. And then right at the tail end, there's a coefficient on 2's connected with x by multiplication. So to undo, you divide. So, okay, so let's divide by negative 2. That'll be good because negative 2 divided by negative 2 is 1. So I'll be left with 1x. And divide by negative 2. Now, a negative divided by a negative is a positive, and you arrive at 31 halves. Now, you might be looking at that saying, hey, I know just from money that $31, cut in half is 15.5. So, but we haven't headed into the chapter on decimals yet. It's okay to give me a decimal. It's also okay, you could say 15 and a half, you could say a mixed number, or you can say 31 halves. So, it's okay to leave it like that for now. I think most of your practice at the beginning is you get a whole number answer. But know that these fractional or decimal answers are coming, especially we have a whole chapter devoted to fractions. So, okay, hope that helps. And like I said, for time's sake, I'm not going to check it. I'm going to go in faith that that's right, because I want to get through our final example. So this is our final example. You may hit pause and try it on your own. Here we go. Distribute, distribute. Negative 2x minus 2 equals negative 3x plus 7. Letter, number, letter, number, letters on the left. Right, so you want to bring negative 3x over. So you want to add 3x. So now you have 1x minus 2 equals 7. Now you've got letter, number, number. You would like to bring this number and toss it across the equal side to meet with that number. But you can't just toss it, but you can add it. Negative 2 plus 2, gone. And 7 plus 2 makes 9. Yay. And 9 would actually be fairly easy to throw back in and check. I did want to mention a little sidebar on checking that. Negative 2 times 9 plus 1. Check to verify that that equals negative 3 times 9 plus 7. Well, let's see. This makes 10. So negative 2 times 10, this makes negative 20. And here we got negative 27 plus 7. Well, hey, that makes negative 20 as well. That's what I mean by verify that throwing that solution back in, verify that it checks. Okay? And you get a true statement here. Negative 20 does equal negative 20. If I would have got a false statement there, I know that answer doesn't it is not the right answer. So I hope that helps. And feel free to go back over any of these problems, and good luck out there.